right, so 9C is still function models and applications. Now we're going to be writing functions from formulas. So, example 6 says the perimeter of a rectangle garden is 84 feet. Express the area as a function of the width W of the side. So we know the perimeter is 84 feet. So remember, for perimeter of a rectangle, perimeter is equal to 2L plus 2W. And if we know the perimeter is 84, we can put that together. And so we know 84 is equal to 2L plus 2W. Now, it wants us to express the area as a function of the width W of the side. So we also know area of a rectangle is length times width. But now it says it wants area as a function of the width. Remember, that means that W is going to be the only variable. So that means that I am going to need to use that other equation to solve for L so that I can plug it into this equation where I only have W as a variable on that one side. So I'm going to go back to that first equation, work a little bit on it. I need to get the W by itself. First thing I notice is it's an equation and all three terms are divisible by 2. So I'm just going to divide that out. So we end up with 42 is equal to L plus W, and then just solve for L. And so we have L is equal to 42 minus W. All right, once we know that, we can come over here, we can plug it in. So we have area is equal to L, which we said is 42 minus W times W. And then we could take and distribute that W to get rid of the parentheses. It looks a little cleaner. And so we get A is equal to 42W minus W squared. All right, example 7 tells us the volume of a right circular cone is V is equal to 1/3 pi r squared h. If the height is twice the radius, it wants us to express the volume V as a function of the radius r. So we want to get V where only r is our variable. Well, we already know from what it showed us there that V is equal to 1/3 pi r squared h. And if I want r to be the only variable, I need to get rid of the h. Well, what else did it tell me? It told me here the height is, so height equals twice, which means 2 times the radius. So we know the height is equal to 2r. So I'm going to take that and plug it in for h and then clean it up. So we got V is equal to 1/3 pi r squared, and we know h is equal to 2r, so substitute it in. So V equals, I'm going to multiply my numbers. I have 1/3 times 2, which is 2/3 pi, and then I have r squared times r, which is r cubed. And then B says find the volume of the paper snow cone cup whose radius is 2 inches. So now I'm looking for the volume, and it told me that radius is 2. So we're going to take the equation we just found. We know our radius is 2, so plug it in and solve. Oops. So if it wanted exact, we know that 2 squared is 4 times 2/3 would be 8/3 pi, and it would be inches cubed because it's volume. Or we could put that in our calculator, 8/3 times pi. Wait a minute. Oh, this is supposed to be cubed. So that would be 2 cubed is 8 times 2, that makes us 16. I apologize. So 16/3 pi, or 16 pi over 3, however you want to look at it, inches cubed. And if we wanted it, if we were able to use our calculator, we want it in a decimal form, type in 16 divided by 3 times pi, or 16 pi divided by 3, and it's going to tell us 16.755, and it's inches cubed. All right, example 8 tells us the grain is leaking through a hole in a storage bin at a constant rate of 6 cubic inches per minute. The grain forms a cone-shaped pile on the ground below. As it grows, the height of the cone always remains equal to its radius. If the cone is 2 feet tall now, how tall will it be in 1 hour? All right, so One thing I noticed is in the problem it told me I see 6 cubic inches, but then I see 2 feet tall. So we need to convert one of those. It's easier to convert feet to inches. So we know that this is just going to be 24 inches because there's 12 inches in a foot. All right. So we're looking at volume. We're talking about the amount of something inside of the storage bin. So we know that volume is equal to 1/3 pi r squared h. And it told us here, as it grows, the height of the cone always remains equal to the radius. So we know that the height is equal to the radius, which means we have V is equal to 1/3 pi r squared times r, or we could say h squared times h, whichever one. And so I just went with the r. So we know it's 1/3 pi r cubed. All right, once we have that, we can start working on what is the volume right now. So it tells us that the cone is 2 feet tall now. So that's our height, same as our radius. So we know, change colors here. So right now, our volume is equal to 1/3 pi times 24 cubed. And so 24 cubed times 1/3. And so we get our volume is equal to 4,608 pi inches cubed. That's what the volume is right now. Now it tells us though that it's increasing, it's leaking through the hole, so the amount on the ground is increasing by 6 cubic inches per hour. So let's look about the increase. So, see my increase, I'm going to write it over here. 6 cubic inches per hour. Oops. I'm sorry, not hour. It's per minute, my bad. All right. So we're wanting to know how much is in 1 hour. That's where I got that from. So my increase if it's 6 cubic inches per hour, we want it, dang it, I'm sorry, per minute. Excuse me. Per minute, we want to know in 1 hour. And so we end up with 360 inches cubed per hour as our increase. So we can use all that, we can put it all together and find out what the volume is in 1 hour. So we're going to take the volume from right now that we had found, which we said was 4,608 pi inches cubed. And we're going to add the increase in that 1 hour. So that's the 360 inches cubed. And that's going to give our new volume. And so I went ahead and did my 4,608 pi plus the 360. And I got 14,836.458 inches cubed. Now, why do I need to know the volume that's going to be there in 1 hour? Because I want to know how tall it's going to be in 1 hour or what the radius is going to be in 1 hour. So, remember, we came up with that equation just a little while ago. We had said that our volume is equal to 1/3 pi r cubed. Well, now we know our volume is 14,836.458. is equal to 1/3 pi, and we're looking, I'm going to change that from r to h because we're after the height. So the height cubed, because remember, the height's equal to the radius. And so I'm just going to work at solving this. And actually, you know what I'm going to do before I actually solve this? I'm going to take this off. I'm going to solve that equation for h. So I'll come back up here. I'm going to change my r to an h in that equation. I think that'll make it easier. Then we can type everything in at once. So since we're after the h, let's get it by itself. So let's multiply by 3. So 3v equals pi h cubed divided by pi. And so we know that 3v over pi equals h cubed. And then to get rid of the cube, we're going to take the cube root of all of it. So h is equal to the cube root of 3v divided by pi. And now let's plug in. So we got h equals the cube root of 3 times v, which we know is at 14,836.458 divided by pi. And so we type this in our calculator, and it's going to tell us that our h is equal to 24.197 inches. All right, and I know we normally don't box or circle answers, but I want to make sure we don't lose that answer because that was a lot of work. All right, then variation problem. So in variation, there's 3 different types of variation we have to think about. And so I'm just going to kind of write a few notes here. So one of them is if we have direct variation. Direct means we're going to multiply. So we're going to have y equals some k, which is called our constant of variation. It's how the things are varying, times x. So direct means they'll multiply. Then you have inverse variation. Inverse means to divide. So you're still going to have y equals k, but because it's inverse, now it's going to be divided by x. And then you have what they call joint variation. Okay, and joint just means you're multiplying multiple variables. So you're going to have your y equals k times, and then it could be multiple variables. So x times z, or k times abc, something like that, okay? So the only one that's different is inverse, and inverse just means to do the opposite. So you're going to divide instead of all the others where you multiply. All right, so when they give you a variation problem, typically what they're going to do is, like the first sentence, they're going to help you set up your equation, how your variation equation is going to be set up. The second sentence is going to tell you all of the variables except k, so that you can solve for k and actually write out your equation. And then after that, they're going to ask the questions of what they want you to find using the equation that you found from like the first 2 sentences, okay? Or from the 2 previous sentences anyways. So let's look at example 9 here. It says Hooke's law states that the force required to stretch or compress a spring by some distance is directly proportional to that distance. A force of 275 newtons stretches a spring 0.2 of a meter. So I'm looking for where it's going to say is directly proportional, varies directly, varies inversely, varies jointly. It's going to either say proportional or varies there, okay? Might say inversely proportional, something like that. So you're looking for the words proportional or varies, so find it. That is your equals k. So I'm going to use this room right here, so I'm going to put equals k. Whatever's in front of that word is what's going to go in front of the equal sign. Well, what is directly proportional? Hooke's law states that the force required to stretch or compress a spring by some distance. So it's the force. So your force is equal to k. Now it says directly, which means we're going to multiply. Well, I'm trying to put my time sign. It's giving me some trouble here. All right, so we're going to multiply. And whatever's after the directly proportional varies word, whatever that word is that you're after there, is what's going to go after the k, whether it's being divided if it was inversely or if it's just right after because it's being multiplied. So it's directly proportional to what? the distance. So there's my D. Now the next sentence is going to give me everything except K. All right, it's going to give me everything but that constant of proportionality so that I can solve for K. So it says a force of 275 newtons stretches a spring 0.2 of a meter. So we know our force is 275. Oops. Okay, I'm sorry. So we know that the force is 275. It says a force of 275 newtons stretches a spring 0.2 of a meter. So equals K times the distance is 0.2. So we're going to solve for K. And so we get K is equal to 275 divided by 0.2 is 1,375. And so we now know that we can take and plug that back into the equation. And so our equation is F is equal to 1,375 times D. Now we can answer question A. Question A says, how far, so we're after the distance, will a force of 620 newtons stretch the spring? So we know our force is 620 equals to 1,375 times D. Solve for D. And so 620 divided by 1,375, we find the distance is equal to 0.451, and distance is in meters. And then B says what force is required, so we're after F, to stretch the spring 0.1 of a meter. Well, we're using the same equation. And we know that we're after F, and our distance is 0.1. And so we find our force is 137.5, and force is measured in newtons. And that is the end of lesson 9.